Welcome to Simultaneous Equations Level 6. Pause the video now, try the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving 3x minus y equals 4 and x squared plus y squared equals 34. Now, since we have a linear and a non-linear equation here, we need to solve these by substitution. And the way that we'd normally do this is to substitute the linear into the non-linear equation. Now here, the linear equation is not written with y or x as a subject, and so we need to start by doing that first. So starting with 3x minus y is equal to 4, we can start by removing the minus y from the left, by adding y to the left and doing the same on the right. So this gives us 3x is equal to 4 plus y. And to now make y the subject, we can remove the 4 from the right by subtracting 4 from the right and doing the same on the left. And so the left becomes 3x minus 4 and the right is just y because the 4 and the minus 4 cancel out. Now that we have y as a subject, we can take 3x minus 4, which we know is equal to y, and substitute it into y in our second nonlinear equation. So that second equation, x squared plus y squared is equal to 34, becomes x squared plus, I'm going to substitute 3x minus 4 for y, but we need to have that in brackets because it's still being squared, and that's equal to 34. And now we have an equation that only contains x's. To continue, we now need to expand the bracket in the middle. So we have x squared plus, and to expand a bracket that's being squared, we can write the bracket out twice because squaring something means it's being multiplied by itself, and that's still equal to 34. So we can now expand the bracket in the middle and say that we have 3x times 3x, which is 9x squared, 3x multiplied by minus 4, which is minus 12x, minus 4 multiplied by 3x, which is minus 12x, and finally minus 4 multiplied by minus 4 gives us plus 16, and that's equal to 34. We can now simplify the left-hand side of the equation by collecting together the like terms. So we have an x squared plus 9x squared, which gives us 10x squared, minus 12x is minus 24x, and we still have a plus 16 on the left and an equals 34 on the right. Now, since we have a quadratic, what we'd like to do is make one side equal to 0. And we can do this by subtracting 34 from the right and making sure that we do exactly the same on the left. So on the left, we have 10x squared minus 24x, and 16 minus 34 is minus 18. And that's now equal to 0 because 34 minus 34 is 0. To solve this quadratic, we could try and factorize, but since we have a 10 in front of our x squared and we can't divide the equation by 10, it's often easier just to go straight to use the quadratic formula. And before we can use this formula, we first need to establish what the values of a, b and c are. So a is the number in front of the x squared, which is 10, b is the number in front of the x, which is minus 24, and c is the constant at the end that's on its own, which is minus 18. So substituting these into the quadratic formula, we have x is equal to minus b. Now b is minus 24, so minus 24 gives us 24, plus or minus the square root of minus 24 squared, because b is minus 24, we need to make sure that we put that in brackets, minus 4 times a, which is 10, times c, which is minus 18, and that's all being divided by 2a, which is 2 times 10. Now if we put this into our calculator with a plus on the numerator, we get x is equal to 3. And if we do the same but using a minus on the numerator, we get that x is equal to minus 3/5 or minus 0.6. So these form the first part of our solution. We now need to find the corresponding y values. And to do this, the easiest equation to use is going to be the equation that we got when we made y the subject. And that was y is equal to 3x minus 4. And so when x is 3, if we substitute this into this equation, we get y is equal to 3 times 3 minus 4. And 3 times 3 is 9, take away 4, gives us 5. So y equals 5 pairs with x equals 3. If we now look at what happens when x is equal to minus 3/5, we have y is equal to 3 multiplied by minus 3/5 minus 4. And 3 multiplied by minus 3/5 minus 4 gives us minus 29 over 5. So y equals minus 29 over 5 pairs with x equals minus 3/5. So our final solution to problem 1 is x equals 3, y equals 5. That's our first pair. And then separately, x is equal to minus 3/5, y is equal to minus 29 over 5. In problem 2, we're solving 2x squared minus xy equals 12 and x minus y equals 4. Now the first equation is nonlinear and the second is linear, so to solve these we need to use substitution. And at the moment we don't have either equation with x or y as a subject, and that's what we need before we can substitute. So looking at the second equation, which looks like the easiest one to use, we can actually just add y to both sides of that equation. And on the left, this just becomes x because the minus y and the plus y cancel out. And on the right, we have 4 plus y. And so we now have x as a subject. And this means that we can take 4 plus y, and in the first equation, wherever we see an x, we can replace that with 4 plus y. So the first equation, 2x squared minus xy is equal to 12, becomes 2 times, now the x is becoming 4 plus y, and it still needs to be squared, minus, and then we have again 4 plus y in place of x, multiplied by y is equal to 12. And what we've achieved here is we now have an equation that's just in terms of y. So we can hopefully expand, simplify, and then solve. Now starting with the first bracket, this is being squared. So we're going to write this as 2 times, and then 4 plus y multiplied by itself. Now the minus that's in front of that next bracket is actually a minus 1. So I'm going to write this as minus 1 multiplied by, and now I'm going to expand. So we have 4 times y, which is 4y, and we have y times y, which is plus y squared, and that's equal to 12. We can now keep expanding. So we have 2 times, and then we have 4 times 4 is 16, 4 times y is plus 4y, y times 4 is plus 4y, and y times y is plus y squared. We can then expand the next bracket. So minus 1 times 4y is minus 4y, and minus 1 times y squared is minus y squared, and that's equal to 12. We can now expand again, so we can multiply everything in the first bracket by 2. We could also simplify first, but I'm going to go straight ahead and multiply. So we have 2 times 16 is 32, 2 times 4y is plus 8y, 2 times 4y again is plus 8y, and 2 times y squared is plus 2y squared. And we still have a minus 4y, a minus y squared, and that's equal to 12. On the left hand side, we can now simplify by collecting together the like terms. So we have 32, and then we have a plus 8y, which is plus 16y, minus 4y gives us a plus 12y. We also have a 2y squared minus y squared, which is just plus y squared, and that's equal to 12. Now, because we have a quadratic, we want this to equal 0, so we're going to subtract 12 from the right and do the same on the left. And I'm also going to put it in the order where I have my squared term first, my y term next, and my constant at the end. So this becomes y squared plus 12y, 32 minus 12 is plus 20, and 12 minus 12 on the right is 0. Now, since we have a single y squared here, the easiest way to solve these tends to be factorising if we can. So we're going to try and factorise this, and to do this we need to look for two numbers that times to make 20 and add to make 12. And those two numbers are 10 and 2, because 10 times 2 is 20 and 10 plus 2 is 12. So this means we can factorise left hand side by putting it into two brackets with a y at the start of each bracket, because y times y is y squared, and our two numbers 10 and 2 just go at the end. So we have a plus 10, a plus 2, and that's equal to 0. And what we now have are two brackets that are multiplying together to make 0. And the only way that this can happen is if the first bracket, y plus 10, is 0, or if the second bracket, y plus 2, is 0. And now we can solve these independently. So if y plus 10 is 0, we can remove the plus 10 by subtracting 10 from both sides. and this gives us y is equal to minus 10. And then moving on to y plus 2, we can do a similar thing by subtracting 2 from the left and also from the right, and this gives us y is equal to minus 2. So these form the first part of our solution. To find the corresponding values of x, we're going to use our rearranged equation, x is equal to 4 plus y, because x is already the subject, and we're going to substitute each of our y values into here. So when y is equal to minus 10, we get that x is equal to 4 added to minus 10. And 4 plus minus 10 is minus 6. So x equals minus 6 pairs with y equals minus 10. Similarly, if we take y equal to minus 2 and substitute it into our equation, we get x is equal to 4 plus minus 2. And 4 plus minus 2 is 2. So x equals 2 pairs with y equals minus 2. So our final solution to problem 2 is x equals minus 6, y equals minus 10, that's our first pair, and x equals 2, y equals minus 2 is our second pair. In problem 3, we're asked to find the coordinates of the points where the lines with equations y minus 2x equals minus 7 and 3y squared plus 2x squared equals 21 meet. Now, if you're ever looking for points of intersection of two graphs, what you want to do is solve their equations simultaneously and then write your solutions as coordinates. So to solve these equations simultaneously, we want to take the linear equation and substitute it into the nonlinear one. Now the problem here is that we don't have x or y as a subject in our linear equation, and so we need to try and make this the case first. So starting with y minus 2x is equal to minus 7, we can quickly make y the subject by removing the minus 2x from the left, and we can do this by adding 2x and doing the same on the right. So the minus 2x and the plus 2x on the left cancel out to just leave us with y, and on the right, minus 7 plus 2x gives us minus 7 plus 2x, or 2x minus 7. And now that we've made y the subject, we can take 2x minus 7, because we now know that's equal to y, and substitute it into the second equation in place of y. So our second equation, 3y squared plus 2x squared is equal to 21, becomes 3 multiplied by 2x minus 7 squared, because we're replacing y with 2x minus 7, plus 2x squared is equal to 21. And we now have an equation that's just in terms of x. So we can now try and expand the brackets. So we have 3 multiplied by, and 2x minus 7 squared can just be written as 2x minus 7 multiplied by 2x minus 7. We have a plus 2x squared after it, and it's still equal to 21. We can leave the 3 where it is at the start and now expand the brackets. So 2x times 2x is 4x squared. 2x times minus 7 is minus 14x. Minus 7 times 2x is minus 14x. And minus 7 times minus 7 gives us plus 49. We still have a plus 2x squared at the end, and that's equal to 21. We can now expand the final bracket by multiplying everything inside the bracket by 3. So 3 multiplied by 4x squared gives us 12x squared. 3 multiplied by minus 14x gives us minus 42x. Again, 3 multiplied by minus 14x gives us another minus 42x. And finally, 3 multiplied by 49 gives us plus 147. We still have a plus 2x squared at the end that we need to not forget about, and that's equal to 21. We can now simplify the left-hand side by collecting together the like terms. So we have a 12x squared and a plus 2x squared. So that's 14x squared. We have a minus 42x minus 42x. That's minus 84x. And we still have a plus 147 is equal to 21. To solve this quadratic, we need to make the right side equal to 0. So we can do this by subtracting 21 from the right and doing the same on the left. And the quadratic then becomes 14x squared minus 84x plus, and 147 minus 21 is 126. And that's now equal to 0. Now we could try and solve this immediately by using the quadratic formula, because we've got a number in front of the x squared that's quite large. We can first try and see if we can divide all of these numbers by 14 to just get an x squared on its own, because those equations tend to be easier to solve. And actually, all of these values can be divided by 14. So if we divide everything in this equation by 14, 14x squared divided by 14 is just x squared. Minus 84 divided by 14 is minus 6, so we have minus 6x. And 126 divided by 14 is plus 9. And 0 divided by 14 is still just 0. If we now want to try and solve this by factorising, we need to find two numbers that multiply to make 9 and add to make minus 6. And there are two numbers, and they are minus 3 and minus 3. So we can factorise the left-hand side by making two brackets, having an x at the start of both, because x times x is x squared, and using our two numbers minus 3 and minus 3 to complete those brackets. And this is still equal to 0. Now we have two brackets multiplying together to make 0, which means that one of those brackets has to be equal to 0. And because both brackets are the same, we're just going to get one solution here. X minus 3 is equal to 0. And if we solve this by adding 3 to the left and adding 3 to the right, we get x is equal to 3. So this is the first part of our solution. To find the corresponding value of y, we now want to take our rearranged equation from earlier in the question, y equals 2x minus 7, because y is written as a subject, and substitute x equals 3 into this. So when x is equal to 3, we have y is equal to 2 times 3 minus 7. 2 times 3 is 6, minus 7 is minus 1, so y is equal to minus 1. And so these make a pair. And so our final solution to problem 3 is going to be this pair written as a coordinate. So we now know that these two lines meet at the point with x coordinate 3 and y coordinate minus 1. So they meet at the point 3 minus 1.